Hello everyone, welcome to my channel Reshma Physics. In this video, let us discuss about the basics required for reflection of light at curved surfaces. Okay, so now first let us see what we are learning in this chapter. So first we are learning to find the normal at curved surfaces. Okay, the second thing we are finding focal length and also the relationship between focal length and radius of curvature. Third, we will draw ray diagrams for concave and convex mirrors. So these topics we are dealing in this chapter. So now let us start our basics. Right? So first, the branch of physics which deals with the light properties, we call it as optics. So what is optics? The branch of physics which deals with light properties, we call it as optics. Right? Now next, definition of light. Yeah, okay. Definition of light. So light is a form of energy. Light is a form of energy which causes sensation of vision. So whatever the things we are seeing around us is only due to the light. Okay. Now next. The next one is, now we defined optics, we defined light. Next is straight line. Next, curved line. Straight line, nothing but the path of light. Right? Straight line, nothing but the path of light. We say no. Light has rectilinear propagation. Rectilinear propagation. Rectilinear propagation means light travels in straight path. So here, straight line how we will define is the path of the light in which light does not change the direction. So straight line. It will move along the straight line itself only. It does not change the direction. Right? Now, curved line is also nothing but the smooth line itself only. But here, at least once the light changes the direction. Now, see, light is moving in such a way. Okay? Now, it has to follow this path. Okay? It has to follow this path. But see, it changed the direction or not? At least once. At least once light changes its direction. Changes its direction. Right? This is about curved line. Next, ray. Ray of light generally we will call ray. Ray means an idealized straight path. Okay, an idealized straight path along which light energy travels in specified direction. direction. Okay. So the branch of physics which deals with the light properties we call optics. Next, light is a form of energy which causes the sensation of vision. Straight line means the path of the light in which light never changes the direction. Curved lines means the path of the light itself only, but at least once it changes the direction. Right? Next, ray of light. Ray means also nothing but the straight line along which the light energy travels in a specified direction. Okay. Now next, now let us move to reflection. So before talking about the definition of reflection, once let us define about mirror, also about normal and medium. All these things. Okay. So first, mirror. Mirror is nothing but a glass plate. Right? A general glass plate which is polished at one side. Polished at one side. Right? Mirror is polished at one side. The other side where we see ourselves, no, that side, plain side, we call it as reflecting surface. Now mirror. These lines, no, these are symbolic representation of polishing. Polished surface. The symbolic representation of polishing. Now this side, one side it is polished, other side will be there, no? That side we call it as a reflecting surface. So what is mirror? A plain glass plate which is polished on one side. We call it as mirror. Next, medium. Medium means the substance which allows light to travel through it. Light to travel through it. Gases, air, right? Liquids. Okay? The substances through which the light can travel. We call it as water. Okay? These all are the substances. We call it as a medium. Now next, let us move to normal. Okay? If we can define normal, no, then we can define reflection perfectly. Now, let us take the plane mirror itself only. The best example for the reflection is plane mirror. I am taking plane mirror. Or let us take a glass slab. Okay. Two mediums we are considering. Medium 1, medium 2, different mediums. Glass, water, like that. Okay. Now, or gas, air. Yeah, gas, it seems I'm talking about air. Air, water, two different mediums. One medium air, one medium water, gas. Right? Now, in between these two, I'm drawing this straight line. So I think you understood this, what this straight line says. See, this straight line is differentiating these two mediums. Okay, or showing a difference between these two mediums, that this is air and this is water. Okay, or I can say the upper surface of water or upper surface of another medium. Means this line acts as boundary or interface. This line acts as boundary or interface which separates the two mediums. Okay, so this line we call it as boundary or interface. So how we can define boundary or interface? The boundary or interface divides two different mediums. Okay, the substance or the physical quantity or a straight line which divides the two mediums or differentiates between the two mediums, we call it as boundary or interface. Now, I'm drawing a straight line which is perpendicular to the boundary. Perpendicular means what? It is making an angle 90 degrees. Perpendicular means what? That particular line which we draw from the boundary makes angle 90 degrees with the boundary. Now this line which is perpendicular to the boundary interface, we call it as normal. We call it as normal. Okay. So what is normal? A line drawn perpendicular to the boundary, we call it as normal. Now, let us take any light source or assume sunlight itself only. Assume that a ray from the light source had fallen on the boundary. A ray from light source have fallen on the boundary. So, or I can also say that a ray from the light source is incident on the boundary. As it is incident on the boundary, we call it as incident ray. What we call? Incident ray. The light ray which is incident on the boundary, we call it as incident ray. Now see this incident ray. How it is looking? It is making certain angle with the normal. It is making certain angle with the normal. So this angle is denoted by small letter I. And this we call it as angle of incidence. Okay, the angle made by incident ray with the normal, we call it as angle of incidence. Now, this incident ray will return back into the same medium. Incident ray traveled in the air, right? And after incident on the boundary, it returned back. Or we can also use the word bounces back. Bounces. It returned back into the same medium. Now we say that light had undergone reflection. So what is reflection? A returning back of light ray in same medium. We call it as reflection. A returning back of light ray in same medium. We call it as a reflection. Okay. So now this ray which undergone reflection, we call it as a reflected ray. Reflected this ray which undergoes the phenomena of reflection. Reflection means returning back of the light into the same medium. So this ray, we call it as a reflected ray. Now see the reflected ray. Reflected ray is also making certain angle with a normal. This we call it as angle of reflection. Angle of reflection. Reflected ray also makes a certain angle with normal, and it is denoted by small letter r. We call it as angle of reflection. Now next, you see here incident ray is making angle with the boundary or surface. This angle let us denote with theta. Here also reflected ray is making certain angle theta with the boundary. So this angle we call it as glancing or grazing angle. We call it as glancing or grazing angle. Right? Now, what we learned about normal, which makes 90 degrees with the boundary or surface. Incident ray, which is incident on boundary. Reflected ray, which is written back into the same medium. Next, angle of incidence. Incident ray making an angle with normal. Angle of reflection. The reflected ray making an angle with normal. Glancing angle. Either incident or reflected ray making angle with the boundary or surface. We call it as glancing or grazing angle. Now next, first let us go for laws of reflection. Two laws are there. First law says that incident ray, a reflected ray, and normal lies in a same plane. Second says that angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. You have to remember this for problems. Angle of incidence is equal to angle of reflection. Do you know why angle of reflection is equal to angle of incidence? So this explanation is given by Fermat's principle. What the Fermat's principle says, you know, light every time chooses the least or small path to travel. Light chooses the least or small path to travel. So as it chooses the least or smaller path, there will be no much variation between angle of incidence and angle of reflection. So only angle of incidence will be equal to angle of reflection. Okay. Now, let us do some problems related to this reflection. So, first model, he will give angle of incidence and will ask to find the grazing angle. How we will find? For example, model 1, angle of incidence is 40 degrees. Asking to find glancing angle. Now let us draw the diagram. Normal, incident ray, angle of incidence is 40 degrees. The reflected ray, angle of reflection. Now we have to find theta. Now mathematics says that, geometry says that exterior angle is equal to sum of interior angles. So now here, what is the exterior angle? Now already we defined normal. What we said? Normal means which makes 90 degrees with the surface, we said. So exterior angle becomes 90 degrees. Now interior angle, one is 40 degrees, other is theta. Okay. So theta equal to 90 minus 40, 50 degrees. One more. Now second model, he gave glancing angle as 60 degrees and asking to find a reflected angle. Same procedure. Now let us draw the dot. Normal surface. Okay. Normal. Angle of incidence, incident ray. Now he is asking to find R, reflected ray, angle of reflection. Now he gave theta. How much he gave? 60 degrees. How to find R? Same procedure. 90 degrees. Okay, 90 degrees. Exterior angle is 90 degrees. Interior angles, angle R plus 60 degrees. So angle R he is asking to find 90 minus 60, 30 degrees. Right? Now next, third mod. Now he gave angle of incidence as some 70 degrees. And he is asking to find angle of reflection. How we will find? So here no need of doing any mathematical part. The second law of reflection says that angle of reflection is equal to angle of incidence. Right? So angle of reflection will also be equal to 70 degrees. Next, fourth model. He gave angle of incidence some 80 degrees, angle of reflection some 20 degrees, and asking to find the angle between incident ray and reflected ray. How we will find? Asking to find the angle between incident ray and a reflected ray. So now first draw the diagram. Surface, normal. How much is angle of incidence? 80 degrees. How much is angle of reflection? 20 degrees. He is asking to find angle between incident ray and reflected ray. As usual, you assume this as theta. Exterior angle equal to summation of interior angles. A very simple method of solving the problems. Hope you understood. Now, by taking this example, you can do number of problems with the different angles, and once you find the angle of incidence, reflection, glancing angle, etc. Angle between the incident and the reflected ray. Okay. Now next one. Now I said that the best example for reflection is plane mirror only. Plain mirror, the best example. When you go for the barber shops, shopping malls, you will see number of mirrors and you will see your multiple images in that mirror. Do you know how the image will form? Now, if this is the mirror, this is the polished surface. Now, this the reflecting surface. The light from me will incident. Okay, I will draw here. Polished surface. Now here, a person has stand. Now, the light from this person will go and incident on the mirror. Mirror means nothing but reflection. Mirror means reflection. Right? Now, this reflects the light. Okay? This mirror reflects the light. In that reflection of light only, we will see our image. Right? First, we will stand in front of the mirror. The light from us will go and fall on the mirror. Mirror again reflects the light back towards us. In that reflected light only, we will see our image. And the images in plane mirror are laterally inverted. See here, ray 1, ray 2. Now this is ray 2 reflected, ray 1. Here laterally inverted, see, ray 1 is coming this side, ray 2 is coming this side. Laterally inverted. Then how we will know whether it is inverted or not? When you stand in front of mirror, your left hand appears as right and your right hand appears as left. This we call laterally inverted. For plane mirrors, image will be laterally inverted. Lateral inversion means the left appears right, right hand appears as left. Okay. So now, I said in shopping malls, number of mirrors are there. Multiple images will be formed. Now, how to find that multiple images? Okay, there is a formula to find the number of images. For example, let us assume that mirror 1, mirror 2 are arranged at 60 degrees. Then how many images will be formed with these mirrors? Now let us see. The formula for finding number of images is n equal to 360 by t. Okay. Now that is 360 by 60. That is 66R. Now what is 6 here? Two conditions are. What is 6? A even number. What is 6? A even number. The first condition says that if you get even number as answer, then just to do n minus 1, 6 minus 1, 5. 5 images are formed. Now the second thing, sometimes we may get odd number. If you get odd number, then don't change the answer. Keep answer as it is. Right? Sometimes you may get answer as, for example, I am saying 7.5, decimal system, decimal number. Right? In such a way, you just remove that 0.5 and approximate to 7. Right? So here, to find the number of images, the formula is 360 by theta. If answer is even number, do n minus 1. If odd number, keep as it is. If you get a decimal number, just remove that point and approximate to the 7. Now next, if we want to find, for example, second model, he gave number of images as 8. He is saying 8 images are formed. Then in what angle the mirrors are arranged, he will ask. Then you write n is equal to 360 by theta minus 1. So n 8, 360 by theta minus 1. 1 you bring to this side, 8 plus 1, 9, 360 by theta. So theta equal to 360 by 9. That is, so the mirrors are arranged at 40-degree angles. Then we got 8 images. So in this way, we will find the number of images. Okay. So in today's video, what we learned, what is optics, what is light, normal, straight line, curved line, reflection, incident ray, angle of incidence, angle of reflection, how to find them, glancing angle, number of images formed, etc. So in my next video, the continuation of this only, we will learn about spherical mirrors. Here in this video, we talked about plane mirrors. In my next video, let us talk about the spherical mirrors. After completion of spherical mirrors, in a general way, let us go towards the chapter reflection of light at curved surfaces. Hope you understood this. You can take different angles and you can find the number of images, or you can take different images and find for your practice. Okay. So as you practice more, subject will become more and more easy. Hope you understood this class. If you like this class, share it, subscribe it. Thank you. Yours, Reshma.